We left off yesterday with talking about, we were in the middle of this central topic, which was designated roots is what it was called. So let's review what we did yesterday. Today is going to look a little bit different, but let's review where we're coming from yesterday. You were given the roots. Do you remember what you turn it into? If you don't know, look at your notes. It says turn the roots into a what? Factors is the word. We take the opposite sign for the factor, and we know how to handle the fraction, bring the denominator to the front, etc. What do you do after you have the factors? You FOIL, right? And because you have to have what kind of equation? Quadratic, which means you need what? X squared. Very good. And then there's also the word equation, which means you need what? An equal sign. So we set it equal to 0. Very good. Okay. Moving forward, they have a little bit of notes to talk about on this one because we have a different situation. Sorry, get my notability set here. For roots with i's and or radicals. So yesterday we had no i's or radicals, but today we are going to. And what we're about to do, I'll just tell you the example that we're going to do has radicals. But if it could have had an I in it, we would have done the exact same thing. Here's what you're going to do on this one. I'll give you even like a step 1, step 2 kind of thing. You're going to set the roots equal to x, combining with plus or minus. You will be given the roots separated, but you're going to put them back together with a plus or minus. You will see, it will make sense to you when you see it, what you do. After you do that, you need to isolate the plus or minus term, whether it has an I in it or a radical or both possibly. That term needs to be gotten alone. After you get it alone, you're going to get rid of it. How do you get rid of square root? Square it. Let's talk about an I. What happens if you square an I? It's negative what? Negative 1. So you've also gotten rid of an I. So squaring will get rid of either a radical or an I, or both. After you do that, I'm going to write, I'm just going to write standard form, I think is what I'm going to say, because after that, you just need to get it into the proper standard form, set equal to 0. I can even do that, throw that in there. But this is your exact roadmap of how to do these. So we're going to practice that one time, and then we're going to move on to our third topic. If you remember yesterday, we did the first topic and then the first half. Now we're finishing up the second half and then the third topic. So we'll finish up our middle topic here and then move on to the last. Example 6. Are we really on 6? Did I do every one of these yesterday? I think I did. Okay, thank you. So picking up here with 6. And then the last topic only has two of them. So 3 examples total today. And then we'll be ready to go. Okay, you ready? Here we go. Write the quadratic equation I did it again today on purpose. What jumps out at you about reading it? Thank you. You remember from yesterday. That is the part that we are striking out. And spoiler alert, in this example, we will actually accomplish that. We will, but it's okay. It's okay that you do. I'm crossing it out to say it's not required. All right, so we have steps on this one, so we're going to go through those, make sure we're following them. What does step number 1 say to do? Set it equal to x, combining with what? What does it say? Combining with a what? Plus or minus. Do you see how the roots that are given are conjugate pairs? Can I say that to you? You know what I'm talking about? Conjugates. So we're going to set this equal to, sorry, not red. Set it equal to an x and combine it as 1 plus or minus radical 2. All right. What does step number 2 say to do? Isolate the plus or minus term. What does that look like in practicality here? This is not a yes question. Answer the question. What does that look like in practicality? So you can read it off the page, isolate the plus or minus term, but can you apply it? What does that look like? The 1. We need to move the 1 to the other side. The 1 does not belong. It needs to go over here with the x. Now we have accomplished isolating the plus or minus term. Now that that is done, what does step number 3 say to do? Square both sides. Okay. Now look at how it says both sides. It does not say every term. It says square the entire side. So can you tell me how to square x minus 1? Square the first, double the product, square the last. Look, it's back again. It comes back when you least expect it. So you need to be prepared for it. Ready? Here we go. Square the first, x squared. Double the product and square the last. Plus 1. Good. Now to the other side. What happens when you square a positive? Positive. What happens when you square a negative? It's positive. So when you square a plus or minus, what happens? It's positive. It goes away. And what happens when you square the square root? It cancels out. So what is that right side squared? 2. What 2 things did we accomplish by squaring? Cancel the radical, also cancel the plus or minus, right? That was why we squared both sides. Because if you are forced to do it on this side, but whatever you do to one side, you have to do it to the other. So that's why you have to square both sides. Hey, and it happened on the left side this time. What else was accomplished by squaring both sides? You got an x squared because we need what? A quadratic. Very good. Okay. How do we think we finish up? And you can look at step number 4. Yeah, we need to put it in what? Standard form. You need to get it set equal to 0. So in practicality, that means you need to put the 2 over there. What does the constant then turn into? -1. Good. And it's set equal to 0. Now we have a quadratic equation as our answer. Do you see how we actually ended up with a leading coefficient 1? We did. And that's okay. It's fine. But so on this kind, that will happen. Do you see, now that you have them both on your paper, one was yesterday and one is today, do you see how the work looks very different? Example 5 to example 6. What is the difference between 5 and 6 that makes the work different? The radicals. Exactly. This has a radical in it. If it had an I, you would have done the exact same thing. You would have just had a little something different in here with the I squared and the negative, all that stuff. But that's the work. Are there any questions? You can put those steps on a note card. Steps can be on a note card. Doesn't it feel like I say something about a note card every day? Okay, this is me telling you. This is the kind of stuff that can be on there. Final topic for lesson 38. We are going to abbreviate overall average rate to be OAR, which I know is OR. We won't call it OR because that sounds like OR. but we will abbreviate it to be OAR because it's kind of a long thing to write out. Overall average rate is talking about big picture on a trip. Okay, so here's the deal. Let's say you have a first, like you're traveling to, let's say, like Tennessee. Okay, so you're kind of a far trip, and maybe you break it up into 2 days, and maybe in the first part of the trip you were averaging, I don't know, maybe like 60 miles per hour. Maybe there was a lot of traffic, and so you were averaging about 60, right? But then day two, not as much traffic, and so then you got to average 80, right? Well, here's the thing. If I asked you, the numbers I just said were 60 and 80. You follow the conversation. If I asked you what was the average speed of the whole trip, you might be tempted to say what number? 70, because that's halfway between 60 and 80. But there is another component that is not taken into consideration. What if I then told you, though, what if I expanded on the story and told you that in a 12-hour trip, like 12 hours from here to Tennessee, give or take, let's say that 60 that I was averaging happened for the first 10 hours of the trip. And I only got to go average of 80 for the last two. Do you think that would affect the overall average? That perhaps it would be closer to 60 because you were doing 60 for longer than you were the 80? Because when I first gave you the situation, you assumed it was about half and half, right? And if it was half and half, then you're right, it would have been 70. But then I gave you more information, told you it wasn't half and half. It was mostly 60 and a little 80. That's going to affect your overall average now. Do you understand this concept? Big picture of what we're doing. That's what we're talking about. Big picture on the whole trip. What is the overall average rate or speed? Here is the formula that you need to know for this. And I think actually before I give you the formula, I want to show you where it comes from because it's really easy and it's related to something that you need to know today. And that is rate times time equals distance. And I'm spreading it out because we're going to be making a table, a chart, like we often do in these word problems. But if I ask you to solve this equation for R, what would you do? You would divide by the t, right? So you agree that R would be equal to d over t. Okay, hold that thought. Now that I give you the formula, does the formula follow and make sense? Do you see the d over t that's in there? Okay, so it's not random, doesn't come from nowhere. It does have a distinction. But the total is referring to how far did you go and how long did it take you to do it. Okay, so you will see, I'll write this down here, build a table, just kind of note. And then after we get the table built, well, you're a little into this concept of doing word problems. So you might see after we get the table kind of where we need to go as far as making an equation. So I'm just going to let that be enough for the notes and we'll see what happens. Are we ready? We have 2 of these and then we are done. Unfortunately, they are word problems, so we got to do a smidge of writing here, but we only have 2 of them. So that's Frank. That's over. Frank and Judy. I did not make these up. These are straight from the book. As with all of our word problems this year, practice is the key. You may not get these at the beginning, but the more we do them, hopefully you continue to get better and better if you work at them, if you put in the effort. Precalc is all about effort. I can give you all the tools, can share with you all the knowledge. I can give you all the recorded lesson videos that you can watch as many times as you want to, but unless you put in the effort, I can't fix that part. I can't do that part for you. So you got to learn it. Okay. So you're definitely looking for those keywords, overall average rate. That's what tells you what kind of problem it is. That's our key bit here. And so we're going to start a table of rate times time equals distance. And the situation this time is not like, I know it talks about Frank and Judy, but are Frank and Judy traveling together or separately? They're going together. So the fact that there are two people is actually irrelevant to the problem. It's just the situation. What does matter is that you have the first, I'm going to call it a leg. I don't know if you ever refer to a trip, like the first leg of a trip, second leg. Anyway, maybe it's a dated word, but that's best word I can think of. What would you call it first? First what? Part? Dip? Day. First day, second day, sure. Anyway, you get the idea. All right. If you look through the situation, it's just different numbers and kind of units or whatever that are given. But it's the same thing I was talking about driving to Tennessee, about the whole 60 and 80 idea. So Frank and Judy drove for 100 miles at 50, but then they kicked it up to 60 for 180 miles. So can we make a little prediction here about our answer? The overall average is going to be between what two numbers? Okay, yeah, you're getting a little more specific, but just in general, between 50 and 60, right? Like you're not going to be outside of that range. And what are we going to be erring closer to? How come? How do you know that? Because they did that longer. You get the idea. This is real life. You can understand it. You can see it. Okay, so be aware of what kind of answer. Let's see what happens when we do this. Let's try filling in the table with the numbers. They drove for 100 miles. What's 100 miles? A distance. Thank you. And they did it at 60 miles per hour. What is that? A rate. Thank you. Stop. Oh, sorry. I did miss the 50. Back to the stop. What is the time? 2 hours. How do we get that time of 2? Do what? It's 150 times 2 is 100, or 100 divided by 50. Right. So we're filling in the 2. So apparently they did that for 2 hours. Okay, moving on. Then they drove 180 miles. What is that? A distance for 60 or at 60 miles per hour. What is that? A rate. Stop. 3. They did that for 3 hours. The question is, what is the overall average rate for the trip? Okay. From the formula, what does the formula say? Total distance over total time. So what is our total distance? 280. And what is the total time? 5. All we have to do is divide that. Do you have an answer? It is 56. 56 what? Miles per hour. Does that go with our prediction? Yes, it does. We didn't know exactly where it would fall, but we knew it had to err a little closer to the 60, and it did very nicely. Okay, the final example is going to throw a little twist in it. Here's a different kind of question it could ask, but we're actually going back to Frank and Judy. They are still in our situation. I'm kind of shorthanding a little bit more, because if you'll notice, what I've written so far is that we're talking about the same situation, but we are going to expand on it a little bit. We're going to talk about their third leg of the trip. And I'm going to abbreviate this overall average rate. So Frank and Judy apparently have a time frame that they need to be arriving at their destination, because they apparently figured out that in order to get there on time, they need to be averaging about 60 miles per hour overall. And with their first two legs of the trip, what is their current overall average? The current overall average, 56. So, but they want it to be 60. So in general, what is the prediction? Like, I'm not talking mathematically, I'm talking in real life. What do they need to do? They need to go faster, right? They need to be going faster in this last leg to be able to make it on time, to hit that goal. Okay. So that's the discussion of kind of what kind of an answer we should be coming up with here, but we need to be going a little faster, and possibly even faster than 60, right? Not just going 60 miles per hour for longer, but you need to maybe even step it up a little bit and go even faster than that. So we'll see what happens. Are we ready to begin? Here's our table beginning. And on this one, we not only have a first and a second, but we also now are adding on a third leg of the trip. So if you were a little unsure about example 7, this is your second chance, because we're going to do running similar numbers as last time. So when I say 100 miles, what is that? A distance. Thank you. And that's at 50 miles per hour. What is that? A rate. Thank you. Stop. What's the time? How much? 2. Next one, 180 miles. What's that? Distance. At 60 miles per hour. Rate. Stop. Fill in the time. 3. Okay, so there's those numbers again. Now for the final question. How fast do we need to drive? So what will we be finding? Not the overall, but just the rate. How fast means we're finding a rate. How fast will they need to be driving for the third leg? The unknown, I'll just call it R for rate, perhaps. You can kind of put a star in there like we do sometimes, if that makes more sense to you, if that's what you're solving for. Okay. How fast do they need to drive for the last 120 miles? What's 120? A distance. That's the distance for the third leg. For the overall to be 60 miles per hour. So a little side note over here, we want our overall to be 60. All right. Now, let's come down here and start some math. The formula, I'm going to jot it down this time, is total distance over total time. We already know the overall. It is 60. So you see how I'm putting a 60 there. Can you tell me how much total distance we have? Is it 400, 300? It is 400. Thank you. Sorry, I was thinking 300, but you're right. It's 400 for our total distance. That's easy. Add up the distances. But then what do you notice about the times? We're missing one. Now, I can put in a temporary t in there, but will that be our final answer? No, because we know that r is the one that we're solving for, right? So you can indicate that to yourself in whatever way. So can you tell me what I write in the denominator of that fraction? Thank you. 5 plus t. Where does the 5 come from? The 2 and the 3. We can add those together but this is going to be 5 plus t. And then this is where we got the 400. If we add them together, they equal 400. Just to make sure I'm not losing anybody. Okay, now let's do the algebra. To do the algebra, we're going to times both sides by the 5 plus t. And when you distribute the 60, can you tell me what we get? 300 plus 60t equals the 400. When I move the 300, what do you get? 100. And when I divide by the 60, what do you get? Give me a fraction. Not 4. 10 over 6, which is 5 over 3. Very good. Drop a 0, and then 10 over 6 is 5 over 3. Okay, almost there, but you have to take that and plug that in to the time right here. So now this is actually 5/3. So now let me pull this out for you so you can see it. You're doing rate times 5/3 equals 120. So what do I need to do to solve for r? Divide by what? 5/3. Yes. Now, what is dividing by 5/3 the same thing as? Multiplying by the reciprocal, which is 3/5. And then let's finish this out. 5 does divide evenly into 120. What is that? 20. Can we not do short division in our head, you guys? 20 what? 24. Can you do 24 times 3 in your head? Think about days, 24 hours. How much is 3 days? 72 hours. Okay, finish the unit and we'll talk about if it makes sense. 72 what? Miles per hour. It is a rate that we are finding. Does that make sense per our discussion? How come? What about it? Yeah, what did we say they needed to do? They need to go faster. And we talked about how it probably even needs to be faster than 60. And it doesn't necessarily need to be within 50 to 60. Probably need to go even faster than 60 to really pull that average up. So they need to really up their game on that. Those are not the easiest problems. They're attainable. It's not high level math, but it is a lot of thinking through and trying to figure out where you're going next kind of thing. So you'll have them. They'll show up in homework. So hopefully you can practice well. Any questions? Okay. All right. So now you understand why we took 2 days on that.